Hello everybody, welcome to my channel. Today we are going to talk about classes. First of all, let me introduce you to the class function. Let's run this line over here. As you see, this is a function that tells me what class and a specific object of R is. And it actually tells me how R is reading a value. And by knowing this, I can understand the properties of that object and how to operate with it. If I run that function for the number 2, I will see that this is a number, it's numeric. Numeric is the first class we are going to talk about today. If I assign this value to an object and now I have it on my working space, I'll see that I can run this line over here and I get that A is a number, it's numeric. If I assign 3 to a B value on my working space, now I can operate both numbers as we saw in the previous video. I can add them or subtract them. There is another super useful function, there is the C function. C is actually a shortcut for concatenating. Concatenating is putting two things together. It allows me to create vectors. A vector is is a collection of a set of values. As an example, I can concatenate the A and B values over here, the ones that I got on my working space, and assign them to X. X is now a vector. In my working space, I can see that X is a numeric value that has two entries, the entries 2 and the entry 3, which corresponds to the values of A and B respectively. However, vector is not a specific class of R. If I run the function on X, I get that X is actually a numeric object. If I create another vector, let's say Y for instance, I concatenate 4 and 7, now I have two vectors in my working space. In here, I will assume that all of you are familiar with basic linear algebra. So as you recall, you can add or subtract two different vectors, provided that both of them have the same number of entries. In here, I can add them or subtract them, and I can see here the two results in my console. R also supports two types of vector multiplication. One of them is an element by element product, which is this line over here. As you can see, we get an two entry vector that corresponds to the specific products of 2 and 4, which is 8, and 3 and 7, which is 21. If I want to do an inner product, which is the basically vector multiplication that appears in linear algebra, I have to use this operation over here, which is the ast in the middle of percentages signs. Here I get a result which is 29. It's actually 2 times 4 plus 3 times 7. Another useful thing that you can do with vectors is to extract a specific value of the vector. This line over here, for instance, will give me the first entry of the object X. For doing that, we use the square brackets. If I run this line over here, I get a 2, which is the first entry of X. If I run this line over here, I get the second entry, which is a 3. I could also replace a specific value by assigning a new number to a specific entry that I want to change. In this case, let's say that I don't want the first entry of X to be 2 anymore. I want it to be 6. So here it is, and as you can see in the working space, X doesn't have anymore a 2 in the first entry. If I call it, I get 6 and 3. The length function tells me the number of entries in a specific vector has. Here we get that x has 2 entries and y has also 2 entries. Another important class is character. A character is basically something that you can put into quotation marks. Here, if I run this line, you'll get that this object is a character. And let me show you something. Let's say that I want to assign this sentence to an object that is called introduction. We say that it has appeared in the working space. Now let's say we want to run this line over here, which is actually my name. And we have two objects, both of them are characters. There is a useful function that is called paste. Paste is a function that operates over certain characters. Paste puts together two different characters into one. If I run this line over here, I will get a complete sentence that is hello, my name is Juan, which is basically the putting together introduction and my name, which are the two objects that I have in my working space. However, there is another paste function that is called paste zero that does something similar. However, if I run this line over here, we can see that Juan, my name, is actually in the same word as is. The reason for that is because the paste function automatically puts a space between the two characters that I want to put together. Paste zero, on the other hand, does not do this. If I want to use paste zero to make a sentence, I have to put the space manually, like this. Now I get the result. Let's say that I want to have an object with the complete sentence in my working space. So let's create it. Now I get complete introduction, and I have the complete sentence over there. And I can call it if I want to see if the object, what class this object is. I get that there is a character as expected. Okay, good. Moving along with a more linear algebra foundations, you know that matrices are quite useful. Actually, they are very important when you're trying to code or when you're trying to program. R has a matrix function that allows you to create a specific matrix when you have given it certain values that you want to put into rows and columns, so you can create a matrix and then operate with it. As you can see, the matrix function asks you to put the data, the number of rows and the number of columns. These arguments allows you to create a matrix. Let's say that I want to create one with 2 rows and 3 columns. This is a 2 times 3 matrix with the objects, the elements 2, 4, 7, 8, 9, and 10. If I run this line over here, let's see what happened in my working space. As you can see, the working space is now divided in 2 parts. One is for values and one is for data. The data is actually any matrix that you want to create, and also some data frames that we're going to talk about in the next video. If I run the class function for R, for A, I get that A is matrix. Matrix is an object, it's a class in R. I want to show you something. Let's say that I want to create the inner product of x and y, as I explained above. And if I run the class function with this operation, I get that, oh, wait, this is a matrix. This is no longer a vector, and this is not longer just a number. It's a matrix. And if I run this line over here, I get that is 45. Recall that I have changed the first number of x, so now I get a different result than before. And as you can see, this one over here and this one over here tells me that the R is arranging my result in matrix form. And this is important because you have to understand that classes is not only to understand how you can or you are able to operate a given object. It's also to understand how the outputs of the codes that you are running are behaving so you can operate over them. Frequently, you you may want to extract a certain value of an output, and to do that, you need to understand what class that object is. Something that is quite useful as well is how to extract elements from a matrix. Here, you will extract the first element of the matrix. In this case, that is a 2. And this operation, as you know, matrix has several dimensions, 2 dimensions, in fact. A vector only has 1. In fact, a matrix can be understood as a collection of vectors. So basically here, what you're doing is allowing R to understand that you want to call a row, and after the comma, you will put any column that you want to call. In here, we are only calling the first row of R and all its columns. So here we get 2, 7, and 9, which is actually the first row of A. Here, on the other hand, you are running the first column, which is 2 and 4. And here, you're calling the second row and second column entry. You get a single value, which is 8. Another way to do that is by concatenating the indices that you want to extract from the matrix. In this case, let's say that you want to take the 2 and 3. And if I run this line over here, you get a 2 times 2 matrix, which is the result of extracting the second and the third matrix. The second and the third column. Similarly, you can do this, which is extracting the first and the second row of the matrix. Let's say that you just want to take the second column. So here you will get one single row, which is actually the first 2 rows of the matrix, but you are only taking one column. Those, if I run A over here, basically what you're having is this second line over here, second column. And the same way as we saw with vectors, you can change a single value. Let's say that the entry 2, 3 corresponds to a 10. Let's say that you want to change it, put the 5 over there, and now here it is. Another useful thing to understand is that when you strike a column or a row, this is no longer a matrix. This is a number. In fact, the reason for that is because R is understanding that output as a vector. And as you saw previously, the vector is of numeric class. Okay, so this operation over here, which is taking the first column, is actually equivalently just to take a concatenation of 2 and 4. This is actually this result as well. Therefore, you can interpret this as a vector, and by running this line over here, you will be able to extract the first entry of this vector over here, which is a 2, and there you have it. Equivalently, you can extract the second value, which now is a 4. Now, let's say that, okay, let's create this matrix over here, this 2 times 3 matrix. A and B have the same dimensions. This means that you can operate them, you can add them, subtract them, and this operation over here is not the regular matrix multiplication. R has two types of multiplications, the same matrix multiplication, the same way as happened with vectors. If you run this, you will get a matrix of the same dimensions of A and B, because what R is actually doing is multiplying element by element. If you want to run the regular matrix multiplication, you have to create a matrix with the proper dimensions. Recall that two matrices are possible to multiply them if the number of rows of the first matrix is equal to the number of columns of the second matrix. So to do that, I run this line over here, and now you get that the result is a 2 times 2 matrix. And the reason for that is because A is a 2 times 3 matrix, while C is a 3 times 2 matrix. This product is possible, and the result is a 2 times 2 matrix. This is something that you should know about your linear algebra foundations. The dim function gives you the dimensions of matrix. If I run this for A, you'll get 2, 3. It means that it has 2 rows and 3 columns. Length gives you the number of total entries that the matrix has. In this case, 6. T is an operation that transposes the matrix. If A is a 2 times 3 matrix, then TA is 3 times 2. Rows becomes the columns, columns become the rows, and that's how it works. And this is the result. N row is the number of rows of A. This is actually an element of dim, is the first element. And column is the number of columns. Let's say now that you need square matrix. D is a 2 times 2 matrix, and because this is a square, you can use the determinant function that gives you the determinant of a given matrix, the square matrix actually. It asks you two arguments over here, the name of the matrix, and this is a logic value that we are going to talk about in the next video. Logarithm tells you whether you like the determinant to be expressed in a logarithmic scale. Let's say that I don't want that. So if I run this line over here, I get that my result has 3 parts. The first one is the actual number of the determinant. It gives me the, the instruction that I gave it when I ran the line, which is false, and it gives me the sign of the determinant. This means that Z has a determinant equal to -10. To check this out, let's run this for a moment. This is a matrix. Recall that the determinant for a 2 times 2 matrix is computed by this 4 minus 7 times 2, and this is the result that this function is giving me over here. The solve function gives me that the inverse of a matrix. Recall that for a matrix to be invertible, you need 2 things. First of all, that the matrix is square, and second of all, that its determinant is non-zero. Both things are true in this case, so the inverse is here. This is an inverse matrix. Just know that D times solve D is actually has to be so this is the time element by element multiplication, but if I do the regular matrix multiplication, I get the identity matrix, which you know that is the result when you multiply a matrix times its inverse matrix. Okay, finally, you can convert one class to another. Let's say that you want to create an object that is called A, and that object is 2 in quotation marks, which is actually, as you already know, a character. A is equal to a character that is 2. There is a family of functions in R that are preceded by f dot. This function converts any given value to a number if it's possible to convert it to a number. Here R will understand that 2 is possible to get it as a number. If I want it again as a character, I'll just do this. And I have a 2 as a character. If I do this, I get that A is a character. You could also convert a vector into a matrix like this. X is 6 and 3. If I run this code over here, now you have a 2-row and 1-column matrix. If you want to convert a matrix into a vector, then you get a different result. In fact, if I run this line over here, then the matrix is no longer arranged in rows and columns. Now you get a single row with all the values of the vector. So thank you very much, and I hope to see you in the next video.